Hello everyone. In this lesson, we're going to introduce you a valve customization tool, Valve Builder. Our learning objectives in this short video is to get familiar with Valve Builder tool so that later you can create a customized control valve component based on the actual valve sketch. Valve Builder is available both in hydraulic library and thermohydraulic library. You need to first find directional control valves extended under library tree. Then the first icon is Valve Builder tool. Briefly speaking, you can design any kind of control valve by 3 steps. First, drawing the flow path. Second, specify the pressure drops for each flow path. Finally, generate the valve model. Once you click the icon, then the main window of Valve Builder will pop up. The top right part contains 3 tabs. Under Valve Sketcher, the structure of directional control valve is defined. You can click and link the red crosses to draw a flow path between different ports. Under second tab, it's used to define the input signal. In third tab, it allows to define nominal density and kinematic viscosity to compute maximum cross-sectional area and flow rates. The top left part lists the flow path between ports already drawn. Each flow path of the top left list can be parameterized in the bottom part of the interface, which will be detailed soon in the coming slides. A traffic light indicator is located at bottom right. There are 3 states: OK, warning, and arrow. Any warning or arrow in the Valve Builder GUI is reported here, with a tooltip explaining the problem once the mouse cursor rests above it. Then we can design or customize our control valve function from this step. First, we need to define the number of ports at both top and bottom side. Second, we need to set the valve positions and its neutral position. After the first 2 steps, we can have updated schematic with required ports and positions. Now we can click and drag the red cross from port to another port to create the flow path. After a baseline design of flow path, we can also add additional function on it. For example, on the left spool position, an orifice could be placed on one flow path to represent flow resistance. Also, for the port that is designed to be plugged in some cases, for example, when the valve is at the red spool position, the C port is plugged, and this flow path from C port is blocked. Command types can be selected between hydraulic pressure, solenoid, pneumatic, or even hand-driven signals. Now after drawing the flow path, we need to set the spool position mapping. In Valve Builder, you can choose the signal command mode. Either it's a pure signal command without any unit, or it can be set as pressure command mode, where a hydraulic pilot pressure is applied on the valve spool. If the valve is selected with signal command mode, then according to valve sketch, a mapping table is provided for us to input valve position and its corresponding input signal value. Of course, you can use any value to define the valve spool position, but be careful with left and right direction. Then in pressure command mode, a control or pilot pressure need to be applied either on one side or on both sides to switch the spool position. The valve spool position will be changed based on calculation of pressure difference. Also, there could be return spring equipped with valve, so don't forget considering the spring forces when you calculate the pressure difference. For more detailed information, please check the help document. After setting the mapping of valve spool position, we can configure the flow path that we drew already during the first step. In this step, we need to determine how much fluid can flow through this path with what opening area. Please check the snapshot on the right-hand side. For flow path between port P and port A, when the spool is in its neutral position, port P and port A is disconnected, while in the leftmost position, they're connected. At the bottom of main window, you can set the maximum area for this flow path. From the second tab, you need to set the fractional area of this flow path when valve is at different position. In our case, only at the leftmost position the valve is fully open. For neutral position and all the rest positions, no flow is expected through the flow path between port P and port A, so they should be all zero. Once you have finished this step, if there is still port unconnected, you need to connect it with hydraulic plug. Now the valve customization job is finished at Valve Builder window. You can click the Generate Valve button to let MSIM generating valve internal structure automatically with hydraulic library and signal controls library components. The valve sketch will be used as component icon once the generation process is finished. If you double-click the generated valve, the internal structure of valve will be displayed. You can already perform a simulation run to test the functionality of this valve. That's all for this short introduction of Valve Builder. Let's summarize for it. Using Valve Builder tool can help you creating or customizing a control valve based on actual schematic. And this customization work can be divided into several steps, which are command type setting, spool position mapping, and flow path configuration. Okay, with this we end our lesson on Valve Builder tool. Thanks.